Good afternoon, ladies and gentlemen. My name is Gubanov Olekigorich and I represent the Metal Invaders team for the Imagine Cup 2016. We would like to present you our newest software platform, GPUDigitalLab. Have you ever been in a Russian school, somewhere near Siberia? What can you remember from your best memories? Well, the education process is pretty formal and very conventional. We use usual books, usual chalkboard, and as a result you have students that are similar to what you can see on the picture below. What can we tell about our education? Do you think that students like it? Do you think that they find the lecture very interesting? Do you really think that that's the best way to teach students in the modern world? I really doubt about it. I really doubt about that stuff. Personally, I could notice a series of problems which are affecting the quality of our schools, such as lack of teachers, poor technological equipment, and obsession with theory. As a result, we have an industry which is out of date and unable to compete with the industry of the Western Europe and the United States. The technological equipment is either manufactured overseas or out of date. There is no single point of control for the industrial process. And there is no way where you could test your theories by performing experiments or during the manufacturing process. As a result, we decided to come up with a platform that would allow collaboration between scientific community and the industrial sector. That's how the idea of GPUDigitalLab was born. It would be a common platform of collaboration for the people from science, industry and technology. We are planning to build a virtual environment for creating and performing experiments using mathematical models, 3D models and initial graphics. And access to such virtual environment should be available from any device which is very inexpensive and very easy to get access to, like for example an Android smartphone or a tablet PC or an iPad iPhone. Well, a little introduction into our technology. We have a technology that will allow to split the complex task which is received which is sent by the user into a set of independent processes called computational agent. A computation agent is a procedure which is controlled by a timer that returns the results of the computation to the main processing kernel. So, we have a cloud server located, cloud portal with a set of scientific experimental tools available on the following website. Using the HTTP protocol or using the cloud services protocol like REST, we are connecting this portal to our computational server. The server receives the tasks, allocates memory for the tasks, and then it decides how many agents you need or how many independent processes you need to process it. Then it sends the data in the task to the execution process, and then it collects the results and returns it either back through the HTTP post request or directly into your REST application. So, for example, you could access this platform using your mobile phone through our client app, which would be available for download on the website of the system. You would connect to the cloud using your username and password. You'll have to register if you are the first-time user. You choose an application from the control panel, and then you send the data to the computational server, which would use the graphics processing unit to perform the necessary computation. For example, you could have the following type of set of services available for you if you are a mathematician, for example. You could do smart statistics, where it will allow to estimate the relationships between independent data sets using our linear regression technology. You could use our services to build a chemical reaction on the level of molecules and on the level of liquids, or level of mixing liquids, and visualize the process. And you could do a little experiment in the area of medical science, where you are sending a DCOM image, which is a 2D image, and then you reconstruct it into a 3D model, which could be saved. These are the services which we currently have. They are nowhere the limit of our system. We work in close collaborations with the scientific institutions throughout Russia and worldwide, and we invite more and more professionals to participate in our technology. So that's pretty much the steps how you must use the system. So you log on to the website, you download client app, then you select a service and put in the data that you would like to use for as your input parameters. You send the data to the cloud server, and then you receive a data packet. All the experiments which are presented by the user could be sent to our visualization hall. It would be an allocation in our data center, where the experiments would be visualized using plasma panels equipped with Kinect sensors to capture the motion and allow the user to manipulate the 3D image. So this is how our console currently looks like, where we are connected to the server, and we use the technology of name pipes to connect client app to the kernel. We could see that here, for example, we have created a pipe and connected a client application here. So we support several network technology mechanisms, like sockets, like for example here we are listening a socket and processing data which is available and in here we would like to show you how we organize how we arrange tasks for the computation. So you could see the date and time of the task as well as the state. At last, we would like to show you a little experiment which we have managed to perform using our technology. It's an experiment in the area of fluid dynamics. As well as the previous one, we tried some experimenting with modern fractals, and the result of our experiment could be seen on the following picture. That's another way to use GPU computing for the computations, for scientific computation in the area of mathematics. We've done some experiments with developing our own rendering system, where we implemented the ray tracing mechanism on the GPU. In here we tried to implement the ray tracing of soft shadows through falls, like you will see sweets falling into the glass box. a little experiment involving particle visualization. So we have more than 2 million particles here existing as independent units and that are controlled by our kernel centrally. So the kernel is a registered COM server that allows you to connect it from your application. For example, you are a scientist, a software engineer. You could connect to the kernel that we provide on our registered servers through the ActiveX or COM object. Every single COM object, as you know, is allocated an ID number, which you could see below. So, we are planning to construct our own data center which will allow us to visualize the achievements of our software platform. We plan to construct this data center in Yekaterinburg, in the scientific park of Yekaterinburg. So, as you can see, there would be a set of dedicated servers which would be monitoring and processing the requests which they would receive from the online system. It would be working 24/7. The results of the experiments would be displayed on the plasma panels, and as I have said before, that those plasma panels would be equipped with the motion capture and capture technology such as Kinect, so it will allow you to manipulate the image that you can see. Well, that's pretty much the specification of the servers that we currently use. So we use an operating system, Windows Server 2012. That's the server-side operating system that our kernel works on. And that's the technologies that we use. Well, you could see latest Visual Studio version, and you could see that we use strong Microsoft technologies such as Microsoft Direct Compute for parallel processing and parallel computing, and Microsoft Direct 3D for 3D graphics. We also use several products from NVIDIA such as Physics Engine and an rendering engine. So that's how a client application would look like, which would be available for scientists to manipulate their experiments. So you register, and then you are directed to your control panel where you could select your experiments. You could create new experiment and you could send it. So you start by creating a project, then you go through, you must put in the relevant name and date of the project, then you choose a mathematical model from your database and 3D models to visualize the results of the outcomes. You must install data sources, so you supply the initial data parameters, and then you are presented with the results of the experiment. Well, let's move a little bit, goes too slow. So as you can see, there would be a timer on the screen which would show how much time is left before the end of the experiment. Your results would be also saved in a database, and the results of the visualization could be presented onto you in a separate area of our software system. Those results can be shared from other scientists connected to the same scientific portal. Well, thank you for your attention. I hope you have enjoyed our presentation.
Thank you.